Hello, I'm Professor Rad, and today we're going to play around with exponential expressions that have negative bases. So we're going to start out with this example here and just play around with these expressions. So the first one says -2 to the second power. Now remember, when these parentheses are around the -2, that means the base is negative. So that means when I do this exponent of 2, I have to have that negative sign there twice. So a negative times a negative is going to give us a positive, and 2 times 2 is a positive 4. All right, let's do this next one. We have -2 to the third power. So that means -2 times -2 times -2. Here, -2 times -2 is positive 4. And positive 4 times -2, a positive times a negative is a negative, and 4 times 2 is 8. Okay, let's do the next one. And what we're looking for here as we go through these is we're kind of looking for some pattern to happen. So keep your eye out and see if you identify a pattern. So we have -2 to the fourth. So that means we're going to have 4 of these. Okay, -2 times -2 is a positive 4. Positive 4 times -2, positive times negative is going to be a negative, and 4 times 2 is 8. And then -8 times -2, so negative times a negative is a positive, and 8 times 2 is 16. All right, let's try the next one. We've got -2 to the fifth. So now we're going to have 5 -2's. All right, -2 times -2 is a positive 4. Positive 4 times -2 is a -8. -8 times a -2 is a positive 16. Positive 16 times -2 is going to be a negative, and 16 times 2, or 16 plus 16, is 32. All right, let's do the next one. This time we're going to have 6 -2's. Whew. All right, -2 times -2 is positive 4. Positive 4 times -2 is -8. -8 times -2, positive 16. Positive times a negative is a negative, and we get 32. Whew. And now a negative times a negative is a positive, and 32 times 2 is 32 plus 32, which is 64. All right, we got 2 more. Do you see a pattern happening yet? Let's see. Now we have 7 of these -2's. 1, 2, 3, 4, 5, 6, 7. Whew. All right, here we go. -2 times -2 is a positive 4. A positive times a negative is a negative, and 4 times 2 gave us 8. Negative times a negative is a positive, and 8 times 2 is 16. Positive times a negative is a negative. 16 times 2 is 32. Negative times a negative is a positive. 32 times 2 is 64. Okay, positive times a negative is a negative. 64 times 2 is the same as 64 plus 64, which is 128. All right, one more, and then we'll see if we can identify the pattern. So -2 to the 8th. We've got 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Okay. -2 times -2 is +4. Positive times a negative is a negative. 4 times 2 is 8. Negative times negative is positive. 8 times 2 is 16. Positive times negative is negative. 16 times 2 is 32. Negative times negative is positive. 32 times 2 is 64. Positive times negative is negative. 64 times 2 is 128. Negative times a negative is a positive this time. And 128 times 2, I'm going to work this one out. 8 and 8 is 16. 4 plus 1 is 5. 2. So negative times negative is positive, and we end up with a positive 256. All right. Whew, that was a lot. So did you notice any patterns as we worked through that? So one thing that I noticed as I worked through is each time I kept getting 4, and then the -8, and then the 16, and the -32. So it was kind of like I repeated the trip each time, except for the very last step. That's where it was different. I also noticed that when I was finding my products, it alternated. So here I had a positive and then a negative and got a positive answer. Here I got positive, negative, positive, negative. Plus, minus, plus, minus, plus. Plus, minus, plus, minus, plus, minus. Plus, minus, plus, minus, plus, minus, plus. So those were some patterns that I was noticing as I was working through. The other pattern I'm noticing here is that my answer was the opposite sign each time. We started with a positive 4, and then we had a negative. Then we had a positive and a negative, a positive, a negative, a positive. And this is going to keep happening because basically to get this answer, I take the previous answer and multiply it by -2. So if I take a negative times a negative, I get a positive. So if I took a positive times a negative, I'm going to get a negative next time. And this back and forth is going to keep happening. So if we correlate that with our exponents, for every even exponent, 2, 4, 6, and 8, we ended up with positive answers. For every negative exponent, 3, 5, and 7, we ended up with negative answers. So this leads us to a theorem. Theorem 4 says if the base of an exponential expression is negative and the exponent is a natural number, then our answer will be positive if that exponent's even and negative if the exponent is odd. In other words, if I take any negative number and I raise it to the 11th power, since 11 is an odd number, my answer is going to be negative. If I take any negative number and I raise it to the 20th power, because 20 is an even number, I'm going to get a positive answer. So if I have a negative and I raise it to the 3rd power, what should I get? Well, since 3 is odd, I should get a negative answer. So we can use this if we want to check our answers for reasonableness, or to make sure maybe we typed something into the calculator and we forgot the parentheses. We can use this theorem to help us identify whether we're getting the right answer or not. So I have a couple of now you try problems here to work through. See if you can figure out what type of number Freddie and Ellie are going to get when they raise their negative numbers to certain powers. In the next video, we're going to talk about a new exponent, an exponent of 0. So I'm looking forward to seeing you then. In the meantime, have a great day.